All right, super. Hi, everybody. I'm Isar Maji. I'm the CEO and co-founder of dataArrows. Energy used for conditioning spaces in commercial buildings represent about 55% of consumption, which is a significant operation cost. Studies have shown about 30% of this energy is being wasted in this type of buildings. Let me give you an example how we waste energy. We all have the experience of feeling too cold in the middle of summer or too hot in the middle of winter inside buildings. When we feel too hot in winter, it means we are overheating spaces, which waste energy and make occupants uncomfortable. And if there are some operable windows in the building, they would most likely open a few of them to balance the condition, and this will further waste energy. But energy and comfort are not the only factors that matters in commercial buildings. Americans on average spend 90% of their time indoors. So indoor air quality plays an important role in our well-being. What percent of buildings do you think have unhealthy air condition? Well, studies have shown more than 90% of the buildings in the US has at least one of their air quality factors out of the safe range. Although COVID-19 has negatively impacted our life, but fortunately, it has raised awareness about the importance of indoor air quality on our health and safety. In addition to health, indoor air quality has also significant impact on our productivity and performance in our daily activities. Studies have shown we lose about 25% of our performance measures at upper limit of the CO2 safe range. Now imagine going beyond the safe level. We also lose 1% of our productivity per each Fahrenheit degree off from optimum condition. Now, the question is, how can we create a healthier indoor space with minimum energy consumption? In order to answer this question, we have to see how we're currently running our facilities. The problem is that building managers ignore the demography and personal preferences of occupants in running HVAC system. They just use some typical set point for the HVAC system and hope all is going to be fine. They ignore several important factors like gender, age, race, and even the type of activities that people do inside buildings. We address this issue by using AI to create an individual-based comfort and health model for occupants based on demographic information, personal preferences, and health condition. The AI model enables us to measure comfort of each occupant in real time, but sensing building air quality attributes and using such occupant comfort and health predictions, our solution provides AI-generated insight and recommendations to managers to avoid overheating or overcooling spaces and achieve more comfortable and healthier indoor air condition. Also, by comparing predicted indoor air condition and assessing actual condition, our solution identifies system failures and false occupant behaviors like opening window in winter. By integrating BIM and IoT, we create digital twin of buildings. Such integration of static building as-built information and dynamic operation data enable us to harness the power of AI for holistic, smart operation of buildings. Our solution saves energy by up to 30%, enhances health and safety of occupants, boosts productivity and performance of occupants by providing better indoor air condition, and reduces reaction time in unsafe situations. The annual growth rate for a smart building management system is more than 11%. This promising rate reflects the demand and importance of technology like our solution for making buildings better living environment. dataArrows offer products that one need to transform a traditional building into a smart building. We have SmartNode, which is smart IoT devices for assessing building air condition and quality. And we have TwinUp, which is a cloud-based solution for integration of data, information visualization, and providing insight and recommendations to managers. Our line of IoT devices addresses several IoT measures such as CO, CO2, temperature, humidity, dust, pressure, organic compound, and many more. TwinUp integrates sensor data, HVAC information, and occupant preferences in a centralized cloud-based platform and shows latest status of in real time, which can be accessed anywhere in the world. TwinUp creates digital twin of buildings in a BIM-based 3D environment for faster and more efficient representation of information. Our solution monitors your facility 24/7 and notifies you if any attribute goes out of a safe range. The technology-agnostic nature of our platform allows collecting information from a wide range of devices and HVAC systems that are already being used in current facilities, in existing facilities. dataArrows is a US-based company. We started as a research group in 2015 at Penn State University. In 2016, our innovation on building information management was awarded by Building Smart International, which is a leading organization in developing standards for BIM. In January 2017, we released a free version of our information management platform and called IFC Miner. I put it on the web, and it was downloaded more than 1,000 times by different professionals across the globe. In January 2019, we incorporated dataArrows to focus on developing solutions for smart buildings, and a year after, we entered market. Ihsan and I are founders of dataArrows. We met at Penn State when we were doing our PhD, and our product is actually the continuation of what we started back then. We benefit from a very strong advisory board, including Dr. John Messner, who is the president of the US National BIM Standard. In dataArrows, we have a strong advisory team. We have a strong R&D team that have patented and trademarked several innovations and products. We have been involved in many national organizations and societies such as AEC, ASHRAE, National BIM Standard, and we benefit technologies and guidelines from Microsoft and an organization like WHO. Since January 2020, when we released our product, we have implemented our technology in 4 different projects, including a university building for energy saving and increasing learning performances, a healthcare facility for health concerns, a grocery store for visitor comfort, and a construction project for quality assurance during construction. In order to give you an example how our product can benefit our customers, I'm just doing a case study here. I'm considering an office building, 4 stories, 135,000 square feet, and I'm considering the average national average in office buildings for energy consumption. And if we do the numbers, we see the annual energy consumption for each running HVAC system for this building going to be about 112 grand. And if we just cut the waste of HVAC system by half, I'm just doing this calculation conservatively, then we are looking at 17 grand saving annually. And if we just do the math based on implementation costs of 25 grand, we see the return of investment is less than 2 years for this project. But that's just energy saving for running HVAC system. But the main benefit is here, increased productivity and performance in occupants. In this case, it's office space, so workers. Decreased sick leaves because of healthier indoor air condition. And also, this project can benefit from tax incentive that some of the states offer for buildings that run sustainably. So these 3 items would benefit this project far more than saving energy in the HVAC system. And with that, I'm going to conclude my presentation. Thank Shadow Ventures for this opportunity, and I look forward to your question in the Hollow Room. Thank you.